Hey everybody, Mr. Kowalczuk here. Today we're going to talk about Unit 10, Lesson 10 for the law of cosines. And that's standard 18.2 and 18.4. I can solve for side lengths and angle values using the law of cosines. And then 18.4 is I can solve application problems for non-right triangles using the law of cosines. So that's what we're going to be talking about today. All right, now. First off, the opener, what you're being asked to do is to solve for x. Now, what I notice here is that I have an opposite pair and another opposite pair. So that points me towards the law of sines. So try this one, and then come on over here and try to solve for the measure of angle z. All right. Hopefully you pause the video and try to solve it. So here, if we look at that, we see we've got 7 and x and 46.5 and 39.4. Our law of sines says that the sine of 46.5 over x is equal to the sine of 39.4 over 7. And we cross multiply and we get 7 sine 46.5 equals x sine 39.4. We divide both sides by the sine of 39.4. And then we get x is approximately 7 times the sine of 46.5 equals that, divided by the sine of 39.4 equals that. 7.99. So we'll round that up to about 8.0. Okay. Now, if I'm solving for the measure of angle z, that's my theta right here. So I've got my one opposite pair there, and I've got 6 and 8 feet here, but I don't have either angle here. So based on what we know so far, you can't solve for the measure of angle z. We don't have enough information yet because we don't have any of the angles. However, today with the law of cosines, we're going to be able to solve in a situation where we only have one set of opposite values, right? We have our angle and our side here, and then we have the two surrounding sides, or the included angle and two surrounding sides and that opposite. So we're going to be able to solve for that. So let's jump down. Now, I will tell you right away that the law of cosines looks like it has a lot of stuff in it. It's like a longish looking formula. However, the first part of it is a Pythagorean theorem. And you know what the Pythagorean theorem is, which is right here. That's going to be c squared equals a squared plus b squared. Okay. And then the next part is 2ab times the cosine of angle c. Now, I want you to pay attention to what I did here. I intentionally used a big C here and a small lowercase c here. And we're going to continue to use that nomenclature with lowercase here and uppercase here. This is going to refer to angle C, and this is going to refer to the side C. So if we look at an illustration of a triangle, how does this play out? Well, we've got triangle A, B, C. Now, opposite side A, just like we did in law of sines, we have side A. Opposite side B, we have side B. And angle C, we have side C. So notice the sides are lowercase and the angles are uppercase. Okay. So this is the basic triangle, obviously, and we're going to be using this notation with uppercase and lowercase letters in all of our three equations for the law of cosines. And the reason why we have three is because we have three sides and we can solve for any of those. So our first one, which we had up here, was c squared equals a squared plus b squared minus 2 times a times b times the cosine of c. So that's if we're solving for side C or the angle C. If we're solving for side A or angle A, then the a squareds equal b squared plus c squared minus 2, and then b and c come here, times the cosine of angle A. So if you notice, these opposite pairs on the ends we have A here on the end and A here there. And then the other letters go in the middle. In this case, it's B and C. So then we'll do the same thing for B squared. We're solving for that. Then if B squared is here, then A squared plus C squared need to go in here, minus 2AC times the cosine of angle B. So any of these formulas work for the law of cosines. It just depends on which side we're solving for. Okay, so it looks like there's a lot of stuff here. Let's put this to use and actually solve a couple problems here, all right? Let's turn on over to the next page and we'll look at the example. Okay. Now, what is the value of A? Round to the nearest tenth. So the steps to solve up here, just like with the law of sines, identify what you're solving for. Okay, what am I solving for? I'm solving for A. Find its opposite pair or partner is going to be this angle right here, right? This is the angle and opposite that is the side. Put those in the first and last position of the law of cosines. All right, so we're solving for A. So we're going to use A squared equals B squared plus C squared minus 2 times B times C times the cosine of angle A, right? It's in the first and last position of the law of cosine. So we've done 1, 2, and 3. Now I fill in the rest of the law of cosines and I solve for my variable. Okay, so now opposite side B is going to be 8, so that's going to go there. Opposite side C is going to be 11, and that's going to go there. Now I don't know what A is, so that's going to remain my variable. Minus 2, now this is lowercase b and lowercase c, so I'm using the sides. So here side C is 11 and side B is 8, so that's times 8 times 11 times the cosine of angle A, which is 35.7. Okay, now what we have to do is we have to carefully calculate out the value for A squared. So let's go ahead and use our calculator. All right, so I'm going to start out and I'm going to do 8 squared is 64. 11 squared is 121 minus 2 times 8 times 11 times the cosine of 35.7 equals 142.926. Now notice this is positive here in my calculator, and I'm subtracting this value that I multiplied together. So I get a subtraction of this much. Now I have to do all of this. 64 plus 121 minus 142.926. And that's going to give me A squared is equal to 42.074. And all I have to do now is just square root both sides and get A is approximately square root my answer from previously, and I get 6.5. I'll round to my nearest 10, like it says in the instructions. Okay, so figure out what you're solving for and plug your values into the law of cosines and solve for your value. Okay, I'm going to stop there. There's plenty of practice problems to do in class. And then there's the one last thing that we're going to do. Oh, right. Sorry, typo. We're going to use the law of cosines. There's just a typo there. And then the next one that we're going to do is we're going to practice using the law of cosines to find angle measures. Now, the angle measures require a little bit more care. So I want you to pay special attention to this particular problem that we're working on here. Now, in triangle QRS, QR is this, RS is that, QS is this. What's the measure of it? Okay, now, I don't know about y'all, but for me, this is hard to visualize. So my diagram, I'm just going to draw any old triangle. And just like in the law of sines, I'm not going to stress about whether or not it's to scale. So QRS. Now, I follow my instructions carefully. QR is 31.9. RS is 25.2, and QS is 37.6. Okay, now what is the measure of angle R? So this is my unknown, my theta, and round to the nearest degree. Okay, now we're going to solve this the same way we solved the previous problem. Identify what you're solving for and find its opposite pair / partner. All right, so we're solving for our unknown angle R. Its opposite pair partner is going to be side QS or lowercase side r. Okay. Now the next step is to put those in the first and last position in the law of cosines. All right, so that means that theta is going to be my unknown angle, and 37.6 is going to be all the way on the other side. So then if this is side R, then we have side Q, and then over here we have side S. So I'm solving for R squared equals Q squared plus S squared minus 2Q times S times the cosine of theta. So again, I've got my R here, my 37.6, and my theta over here, which is its opposite partner that I don't know, and I'm solving for. So I plugged all that in. Now my next step is to fill in the rest of the law of cosines and solve for the variable. Okay, so R squared is going to be 37.6 squared equals 31.9 squared plus 25.2 squared minus 2, 31.9, 25.2 times the cosine of theta. Now this solving for angles requires a little bit more care, so please pay attention to these next couple steps. Don't just skip through the video and fast forward it. Okay. All right, so 37.6 squared equals 1413.76. 1413.76 equals 31.9 squared plus 25.2 squared. So these two numbers squared together added up give me 1652.65. Okay, now the reason why I didn't subtract this number from that is because it's multiplied by the cosine of theta. So if I subtract this, I'm going to multiply 2 times 31.9 times 25.2. 2 times 31.9 times 25.2. And that gives me 1607.76. 1607.76 cosine of theta. Now I'm going to pause here for just a second. I want to show you something. These numbers are big and they're decimals and whatnot, but they're very, very, very similar to another kind of equation which we've done before. That is real similar. So imagine you have something that looks like this. 10 equals 16 minus 2x. And how would you solve that equation? Well, the way that you would do that, right, is you would subtract 16 from both sides to try to isolate the x, and you would get -6 equals -2x. And then you divide by -2, divide by -2, and you get x is equal to a +3. So you've done that before a whole bunch, and you can do that. This equation down here is exactly the same as something like that. So the numbers are just a little bit bigger, and instead of x, we're solving for the cosine of theta. So you see how it's similar, how we have this number that matches up with the 10, this number that matches up with 16, and this number cosine x matches up with the -2x up here. It's almost like this thing here is just, instead of x, it's cosine theta. So we solve those the same exact way. So let's go ahead and move forward with that. All right, so we're going to solve, just like we subtracted 16 up here, we're going to subtract 1652.65 from both sides. Now, I don't want to do that. I'm going to use my calculator for sure. So that gives us 1413.76 minus 1652.65. Gotta be careful. Okay. -238.89. -238.89 equals, this cancels out, that goes away, a negative, I can't forget my negative, 1607.76 cosine of theta. All right, now just like up above where we divided by -2, we're going to divide by this big number here. So we divide this by -1607.76, and we divide this by -1607.76. All right, now that's going to give me a cosine of theta is equal to, and I'm going to write all this out. The negatives are going to cancel, so that's helpful. 238.89 divided by 1607.76. Now remember, when we're solving for the cosine of theta, or we're trying to solve for the angle, we've got to use our inverse cosine. So now I can undo this with the inverse function of saying, and I'm just going to switch sides, theta is equal to the inverse cosine of 238.89 divided by 1607.76. And then I plug this into my calculator to get my angle theta. So let's go 238.89 divided by 1607. Oh, can't see that. 1607.76 equals. All right, now that's the number that I need to take the inverse cosine of. So now I'm going to do second cosine, and then my answer for my previous, close parentheses, equals. And that tells me that theta is approximately 81.5 degrees. All right, now just to review, with this problem, the important step is two parts. We just add these two numbers together, and then we multiply these together separately. We don't combine those, right? So we get our first number here, and we subtract this cosine of theta with that coefficient there. Okay, we don't combine them because they're not like terms, because this is a cosine of theta on it and this does not. Then we subtract this from the other side. We divide by the coefficient in front of theta, cosine of theta, and then we take the inverse cosine down here of this division in order to get our angle. Okay, all right, good work. And we will see you in class for lots of extra practice problems. Adios.